Imagine a small metal sphere about the size of a tennis ball, a sphere that looked harmless, kept in a metal box inside a laboratory. But this sphere had within it the capacity to release enough energy to destroy an entire city. This was the plutonium core of an atomic bomb, a core that became known as the Demon Core. It was built in 1945, right after the bombings of Hiroshima and Nagasaki. It was supposed to be used as a third atomic bomb on Japan, but Japan surrendered before that. And the core stayed in Los Alamos, used in criticality experiments on tests to understand how close you can get to a critical mass without a nuclear explosion. These experiments, done manually with metal blocks and even a screwdriver, ended up causing two tragedies. Two young and brilliant scientists died after being exposed to fatal doses of radiation. The Demon Core never exploded in combat, but it killed. This is the story of the Demon Core, the deadly sphere of the Manhattan Project. The story we're going to learn today is a direct sequel to the one I told here in my book, The Atom as a Weapon. And if you want to get this book here with my autograph and a dedication for you, just wait until the end of the video and I'll tell you, okay? Now let's get to our story. In 1939, German scientists had managed to split the uranium atom. The news spread through the scientific world like lightning. It was now possible to release enormous amounts of energy by splitting atomic nuclei. If someone could control this chain reaction, it could create both a new form of energy and also a weapon of devastating power. In the United States, refugee physicists from Europe, Albert Einstein and Leo Szilard, warned the American government that Germany might be developing an atomic bomb. And then President Franklin Roosevelt authorized the initial steps of what would become the Manhattan Project, a gigantic effort to build this weapon before the Nazis could get it. The Manhattan Project involved more than 120,000 people in dozens of secret facilities. In Oak Ridge, Tennessee, an entire city was built to enrich uranium. In Hanford, Washington State, nuclear reactors produce plutonium. And in Los Alamos, New Mexico, there was the Central Laboratory, where the best scientists in the world, under the leadership of Robert Oppenheimer, designed and assembled the bombs. There were two parallel lines of research. The first was a uranium-235 bomb simpler called gun type or ballistic type. This was the little boy bomb, which was dropped on Hiroshima. A second type was the plutonium-239 bomb, much more complex, based on the implosion model. This was the Fat Man bomb, dropped on Nagasaki. But Los Alamos didn't just make two bombs. The site was supposed to function as a continuous production line. A third weapon was already being manufactured in case Japan did not surrender. And that's when the core was created, which would later be nicknamed the Demon Core. The Demon Core was produced in Los Alamos in the summer of 1945. It was a metallic sphere weighing 6 kilos and 200 grams of plutonium gallium, about 9 centimeters in diameter. Pure plutonium is quite unstable in several forms, but mixing it with gallium stabilized it in its so-called delta phase, which made it easier to shape. The sphere was made up of two semicircular halves, or hemispheres, fitted together with an intermediate ring called the anti-jet ring. This ring helped reduce neutron leakage through the junctions of the two hemispheres. The entire assembly was coated with a layer of nickel to protect it from corrosion. The molded hemispheres of plutonium gallium were highly radioactive, but they were not critical under normal conditions. This means that by themselves they were not capable of initiating a sustained chain reaction. To achieve this criticality, three main conditions could be induced. The first of these was the compression of the core. You could use explosives symmetrically distributed around the core to increase its density and efficiency in capturing neutrons through an implosion. This method was used in Fat Man-type bombs. The second method is simply adding more mass. By combining more fissile material to the existing experiment, you could then make it critical. The third method would be to use neutron reflectors. These materials, like beryllium or tungsten, reflected escaping neutrons back into the core, thus increasing the fission rate. The initial plan was to use this third core, known as Rufus, as a third Fat Man-type atomic bomb. The possible target of this bomb was still under discussion, but it would probably be Kokura, the city that was spared in the second bombing. However, the Japanese surrender on August 15, 1945, right after the bombings of Hiroshima and Nagasaki, made its use unnecessary. The core was then stored at Los Alamos, and the scientists decided to use it to conduct criticality experiments. This here is a Geiger counter, which, by the way, we're going to take to the United States on our Atom mission next month. This little device here measures the ambient radiation dose, or the radiation from any material near you, so you can see how much radiation that material contains. The amount of radiation a human can safely receive in a year is approximately 1 millisievert. We're going to see how two scientists from the Manhattan Project received much higher doses while handling the Demon core. When we talk about critical mass, we mean the minimum amount of fissile material needed to sustain a nuclear chain reaction. For plutonium-239, it depends on several factors. First, the shape of the mass, its purity, the presence of impurities, and especially the neutron reflectors that can be used. When a neutron hits a plutonium nucleus, it can cause fission, releasing energy and also more neutrons. If many of those neutrons escape, the reaction will simply stop. But if you use reflectors around, those reflectors will bounce the neutrons back inside, increasing the chances of new fissions. Thus, the effective critical mass can be much smaller. The criticality experiments at Los Alamos were aimed precisely at measuring this effect. A plutonium core was placed on a table, and blocks of tungsten or hemispheres of beryllium were brought close to it, almost enclosing the material around that sphere. Measurements were then taken with the detectors to know when the core was about to reach criticality. It was cutting-edge science, but also an extremely dangerous practice. At that time, scientists handled the blocks manually, often without any kind of protection, relying only on their own attention. And that boldness would soon, very soon, take its toll. The first fatal accident happened on August 21st, 1945, just a few days after Japan's surrender. The main character was the physicist Harry Daghlian, only 24 years old, who had been working at Los Alamos since the previous year. That night, he was alone in a laboratory, conducting an experiment with the Demon core. The goal was to surround the sphere with blocks of tungsten carbide, a very efficient reflector, and measure how the neutron rate changed as he added the blocks. This work was very delicate, and each block brought the core closer to critical conditions. Daghlian carefully measured the counts with the detectors he had on the table, but in a moment of carelessness, while trying to position one more block, the piece slipped from his hand and fell directly onto the arrangement. This simple movement closed the configuration and caused the core to become supercritical for an instant. A very strong blue flash lit up the entire room, a result of the ionization of the air by the intense radiation. Daghlian quickly noticed the mistake and tried to remove the block by hand. He even managed to stop the reaction, but he had already been hit by a massive dose of radiation. It is estimated that Daghlian received somewhere between 200 and 300 rads of neutrons and about 100 rads of gamma radiation. That's the equivalent of what a human being should safely absorb in 3,000 years. Daghlian felt nauseous almost immediately. He was hospitalized, but the damage at that point was already irreversible. During the following days, several severe burns appeared on his body. He suffered hair loss, vomiting, and also deterioration of his immune system. His white blood cells simply disappeared, and his body lost the ability to fight infections. For 25 days, he endured an extreme suffering, passing away on September 15th, 1945, at the age of 24. Harry Daghlian became the first victim of the Demon Corps. Military police officer Robert Daghlian, who was in the room with him, was also exposed to high radiation. He became ill but didn't die right away. Even so, he lived the rest of his life with the after effects from the exposure and ended up dying at 62 years old, a victim of leukemia. The Daghlian accident should have been a warning, but less than a year later, another physicist would repeat the tragedy. On May 21, 1946, the second accident with the Demon Corps happened. The protagonist this time was the physicist Louis Alexander Slotin, a 35-year-old Canadian. Slotin was a talented scientist, but also very daring. He had worked in Chicago at the beginning of the Manhattan Project, alongside Enrico Fermi, helping him assemble the first nuclear reactor in history, which was activated in December 1942. After that, he was transferred to Los Alamos, where he specialized in handling plutonium cores. He had so much experience with this practice that he was known as the bomb's armorer. On that day, Slotin was demonstrating to colleagues how to conduct a criticality test with the plutonium core. The method was very simple, but also very risky. He placed the sphere inside two beryllium shells, which acted as reflectors. The two halves were brought together manually, and to prevent them from closing completely, Slotin was using a screwdriver held between the two hemispheres. It was a technique informally called tickling the dragon's tail, or tickling the dragon's tail. The name already made the risk very clear. It was about provoking an unknown power whose nature and strength could be uncontrollable, and just a small mistake could already be fatal. The rules of the experiment included the use of separators between the two hemispheres, but for some reason of his own, Slotin decided that on that day, separators simply weren't necessary. He confidently handled the shells in front of 7 colleagues in the room, some of them positioned right behind Slotin, but at an unfortunate moment, the screwdriver slipped from his hand. The two beryllium hemispheres closed over the core, and instantly, the Demon Core went critical. A blue flash once again lit up the entire room, and Slotin instinctively separated the two halves, stopping the reaction. But again, it was too late. He had received a massive dose of radiation, something like 1,000 rads of neutrons and more than 100 rads of gamma rays in less than a second. That's the equivalent of what a human should safely receive over 10,000 years. And it was the highest acute dose of radiation ever recorded in a human being up to that point. Slotin felt heat and nausea, immediately turned to his colleagues and said, "I'm dead." And he was right. Slotin was taken to the Los Alamos Hospital and spent the next 9 days battling acute radiation syndrome. He went through incessant vomiting, pain, a drastic drop in white blood cells, and eventually suffered multiple organ failure. He died at the age of 35 on May 30, 1946. Among the others present, the physicist Alvin Graves stands out as he received the highest secondary dose, about 166 rads, and was hospitalized for several weeks. He survived, but years later developed health problems, which may have been a consequence of that exposure. This accident had a major impact in Los Alamos and throughout the entire scientific community. It was the final proof these manual experiments were unsustainable, and from then on, criticality tests were never done by hand again. remote equipment, mechanical arms, and various personal protective measures became mandatory. It's important to remember that Harry Daghlian and Lois Slotin were not just statistics in radiation reports. They were brilliant young men with very promising careers. Harry Daghlian was born in 1921 in Connecticut, the son of Armenian immigrants. From a very young age, he showed an interest in physics and graduated from Purdue University, being recruited for the Manhattan Project in 1944. He worked on theoretical calculations and criticality experiments and was only 24 years old when he died, leaving behind a devastated family and friends in shock. Louis Slotin, in turn, was born in 1910 in Winnipeg, Canada. He was the son of Ukrainian immigrants and graduated in chemistry, earning his doctorate in London. Slotin also worked at the famous Cavendish Laboratory at the University of Cambridge in the United Kingdom. And in Chicago, he was part of the team that built the first atomic pile in history, Fermi's first reactor. The first controlled chain reaction in December 1942. He was known for his skillful handling of equipment and his extreme courage in dealing with radioactive materials, but that courage bordered on recklessness. After his death, he was remembered as a hero for protecting his colleagues in the room, but he was also criticized for exposing himself to unnecessary risks. Both of them involuntarily became symbols of the dangers of nuclear science. After Slotin's death, it became clear that the Demon core could no longer be used in routine experiments. That warhead was scheduled to be used in the Operation Crossroads nuclear tests at Bikini Atoll in July 1946. It would be the core of the Charlie bomb, the third detonation after the Abel and Baker bombs. However, after the accident in May of that year, it was decided that the core should be kept in Los Alamos until it was safe to send it to the Pacific. But when the underwater Baker test was conducted on July 25th, it severely contaminated Bikini Atoll and the target ships with a very high level of radioactivity. The conditions were so dangerous that the third test, Charlie, ended up being canceled. And in this way, the Demon core was never detonated. In August of 1946, it was melted down and its plutonium was recycled, being used in other atomic bomb cores. The physical object, called the Demon core, ceased to exist. A core that was never used in war, but that killed 2 men and forever changed nuclear safety protocols. If you enjoyed this story and want to know how things got to this point, just read my book, The Atom as a Weapon, A Brief History of the Development and Use of Atomic Bombs. In this book, you'll understand in simple, didactic, and very direct language, just like you're used to here in the War Room, how nuclear science from the early 20th century turned into the atomic bombs of World War II, which ended up bringing the conflict to a close. And if you're interested in getting your own signed copy, autographed, with a dedication from me, just send an email to saladagera@gmail.com with your full address, including your zone improvement plan code, because I'll calculate the shipping costs so you can receive the book at your home, all right? So hurry up to get yours. If you like this video, share it with your friends and also give us a thumbs up. Don't forget to subscribe to the War Room so you don't miss anything else. I'll stop here. Thank you again for watching, and a big hug from the War Room.